Hello everyone, in this video I'm just going to refactor my code so that we can prepare it for the upcoming videos. Now this is an important video because you have to keep track on what's going on. Now look, the types of algorithms that we're going to in the upcoming videos like implement on our linked list will be the following. We're going to have, for this singly linked list, we're going to insert at end, we're going to insert in the beginning, insert in the middle. Insert at end is also known as inserting at tail, and insert in the beginning is also known as inserting at head. Alright, so then what we want to basically do is the following. We don't want to come over here and write, if you want to insert at the head, we don't want to say head.next or tail.next or whatever, we don't want to do that. We just want to do one simple thing, which is write a function like insert at tail. Alright, and it's gonna insert at the tail, and we're gonna write inside of the brackets what we want to insert at the tail. That's what we want to implement inside of the main function. We don't want to come inside of this and write some complex logic that's going to confuse us later. For example, head.next is equal to tail, or head.data, it gets a bit complicated. So we want to hide all of that complex code inside of our class and basically implement abstraction. The way we would do this is the following. We're going to create a class called linked list. And by the way, if you don't understand what I'm doing, just bear with me. It's alright. I also didn't the first time I came across this. I had to sit down and think about it. So we take this class node, which we created in our previous video. Let's put a semicolon. And we're going to put it inside of here, our linked list, and we're going to keep it private. Okay, so now we put a class inside of another class. If you didn't know, you can do that in C++. Then after that, what we want to do is we want to create inside of this linked list class, but outside of the node class, we want to create something. We want to create a node. Okay, and we were going to create a head node. We were creating this. Alright, now once we actually created this node or this head node, we want to create everything after that public. And for now I can empty my main function. Okay, now inside of this I'm going to have a void, or actually not void, let me create a constructor for my linked list class. And while I'm doing that, I'm just going to say this head node. I'm not going to pass any parameter inside of it. I'm just going to say whenever I create this linked list class, I want the head node created and I want the head to be null. Why did I do this? What head equal to null means is the following. Because remember, head is a pointer, so I have no nodes inside of my linked list yet when I create it. Okay, so if I come over here in the main function, just enter. So I'm in my main function and I'm creating my linked list class, and I'm going to call this linked list ll. Just let me call it ll. Now I'm going to call ll dot insert, and I'm going to put some data inside of it. Now of course I haven't created the insert function yet, don't worry about that. But before I insert this, okay, the head is null. Just remember, whenever head is null, it means that there's no node that exists inside of the linked list. Just think of it like that. I know it's getting a bit complex, but the moment you just think of it like that, bear with me, you're gonna be fine. After that I can just come over here and I'm gonna, where's my Okay, insert at tail, insert at end. Okay, so I'm just going to say insert at tail, and I'm going to just create the prototypes of these functions for all of these other functions. Okay, insert at tail, insert at head, insert in middle. Okay, so I'm just creating these functions, and that's just what it is. In the next video, we're going to implement these algorithms by coding them, of course. Thanks for watching.